So I have my piece of paper landscape. Do you have yours? Landscape? Okay. I'm going to take the top of it. I'm going to fold it down about an inch or so and make a crease all the way across. And while it's still folded, you might be able to do it the other way. I need to do it this way. While it's still folded, I'm going to put my pencil underneath and draw right along the crease, because then I get a really nice straight line. Got that? Yeah? Oh wait, it's okay. Now I'm going to take the right hand side and fold it over, but it's not going to be all the way over. Do you see that? It's only like about halfway of halfway-ish. Does that make sense? Okay. Now this time when I draw my line, I'm not going to start at the edge. I'm going to start at the line I just made. So it looks like that. See, it's not drawn up here. That's just a fold. So I have this. You ready? So part of what I need you to be able to do is I need you to be able to classify numbers. I need to be able to tell you a number and you tell me what kind of number it is. Okay? Or I need to be able to use a vocabulary word and you know what I mean. So we're going to use this. We're going to draw a picture of numbers to help us figure that out. All right? So I'm going to title this right up here at the top in this big section up here, big letters. I'm going to title it Real Numbers. Because that's what this whole page is about, real numbers. There's always some crazy kid in my class who's like, ha ha ha, does that mean there's fake numbers? Well, no, there's imaginary numbers, and we're going to study those this year. That's a little foreshadowing for you. Okay? So there's a symbol that we use to represent real numbers. What does it look like? An R with the extra line, right? Each one of these today, almost, will have a number or a letter that, well, not letter, really, a symbol that represents the name of the number. And you've got to know that because sometimes in your textbook they use that symbol and you don't want to have to keep looking it up every time, so we want you to know it. Okay? So let's start in the big section right here. Okay? I'm going to zoom in on the big section so it makes it a little easier for you to see. Okay? Right in the middle of the big section, we start with a set of numbers called natural numbers. What kind of symbol do you think we would use for natural numbers? An N, but it has to be special, right? So an N with an extra line on the side. Ooh, fancy. What kind of numbers are natural numbers? These are also sometimes called counting numbers, right? So does that make sense that they would be 1, 2, 3, 4, and so on? That's how you learn to count, right? Okay? Natural numbers. Any questions about natural numbers? What comes next? Natural numbers, these things are like natural numbers are included as part of this kind of number. That's a good guess. They're whole numbers. What sort of symbol do you think represents whole numbers? A W, but this one actually has 2 extra lines. Ooh, very fancy. So what's a whole number that's not a natural number? There's only one. 0. 0 is a whole number, but it's not a natural number. Is 2 a natural number? Is 2 a whole number? Yes, see how it's inside of that circle of whole numbers? Okay? All right, so next we have, nope, almost. Yep. Integers. What sort of symbol do you think we'll use for integers? Now, do you think that would be a good choice if we chose I? Why would it not be a good choice? Because I sure looks a lot like a 1, right? So we don't choose I for integers. Think about what it might be for us to use integers. A Z. Yeah, a Z. But it has to be fancy. What's an integer that is not a whole number or a natural number? Negatives. So like -1, -2, -3, and so on, right? So is 2 a whole number? Is 2 a natural number? Is 2 an integer? Is -2 a natural number? Why not? Yeah, it's outside of the natural number circle, right? Only the things that are inside that circle can be that thing. Okay? Should I say that again? Is -2 a natural number? No. It would have to be inside only this circle for it to be a natural number, right? But a 2 is a natural number and a whole number, because see how it's inside the circle? And 2 is an integer because it's also inside the big circle. You okay with that?
So natural is always going to be in part of all things.
Yes. Natural is part of all the things.
But nothing inside, outside.
Nothing outside is that thing. Correct. That's correct. Okay? All right, Liz. What is this big section called on this side? Rational. What symbol do you think we use to represent rational? Right? That would be first obvious, right? R, except we already use it. So we use the next most obvious letter. You know, Q. That is not rational, so sorry about that. I try to make it clear, but yeah. So can you give me an example of a rational number? 1/2. 3.7. What else? 1.5. Oh, so we have decimals and fractions? Okay. Let's get at least one more example that's different than these three. I still need one more example that's different than these 4. How about -1.5? Right? We want to make sure all of them are represented if we're going to try to, give an example of different kinds, right? So, by definition, a rational number a ratio is a number that can be written as a fraction. Okay? So a rational number is a number that can be written as a fraction. So what goes over here in this small section over here? Irrational. And using logic, an irrational number is a number that cannot be written as a fraction. So what numbers do you know of that cannot be written as fractions? The square root of 3. What's the most famous number that cannot be written as a fraction? Pi. I got another one for you. You ready for it? I know that you have been told your whole life that E is a letter. That's because it is. But in Algebra 2, we also use it to represent a number. Okay? We're going to talk about the number E this year. I'll define it for you when you get there, but I need you to know that it's an irrational number. It's a number that cannot be written as a fraction. Got it? Any questions about this so far? So if I said, tell me the odd whole numbers less than 8, what are you going to say? 1, 3, 5, and 7, right? Could you actually even write that down for me? You can, and I want to make sure you understand how you would write it. Okay? So on your notebook paper that you also have out, here's some notes for the day. What's important for us to have at the top of every page of notes? The title, what do you think the title is for today? Domain. And how did I know it was domain? It's on the sideboard. You already wrote it down, right? And I also want to put another title on it. Number classification. Because honestly, the first part of the notes is about number classification. Okay? What's the other thing that we need to have at the top of every days of notes? The date. 8/25. So if I say to you, what did I say? The odd whole numbers less than 8, is that what I said? Can I change it up real quick? Because I want to try to trick you. Is that okay? So I want the odd whole numbers less than 9. We're talking about sets of numbers. So when we write our answer, we have to write our answer as a set. So tell me what you think the answer is. Odd whole numbers less than 9. 1, 3, 5, 7. What? But it says odd numbers. 9 is an odd number. 9 is not less than 9, is it? Good job. So sometimes I'm going to try to trick you and win. Today I tried to trick you and lost. Because you beat me. Okay? What about integers less than 2? Integers, that's the wrong one. Integers are all the numbers included in this circle plus all the inner numbers. So what are the integers less than 2? 1, 0, -1, -2. How many do I have to write? Well, we have to write all of them, right? How many are there? There's an infinite number, right? So how many do I want you to actually write? 4. Unless there's like 10 or less. Okay? But how am I going to do that? Because I still need to represent all of them. I do, right? So all the integers less than 2. And remember, we always list these from least to greatest. What's the lowest integer less than 2? That's the ... isn't it? ... comma, -2, -1, 0, and 1. Does that make sense? I start with the least. Least. Because it's negatives, it's going to go all the way that way. Okay? What about integers? Ask me, please. I started with the least here. I started with the least here. When I do this one, I'm going to start with the least. Okay? Integers less than, except it's supposed to be greater than. Integers greater than or equal to 50. What is the lowest integer greater than or equal to 50? 50, right? 50. Then what comes next? 51. Dot, dot, dot. We know it's 54 and 55 and 56, but again, it goes to infinity, doesn't it? And if I want to ever be able to finish my homework, before I die when I'm 90 years old, I got to stop at some point. Or 95 or 106 or however long. It doesn't matter. Any questions about if I give you like something like this, can you give me a classification of the numbers? You good with those? Okay. So now let's talk about domain. So I've got a number line and then I've got an orange highlight to tell you about my domain. Okay? There's 3 different ways that I need you to be able to write this domain. I need you to be able to write it in inequality notation. I need you to write it in interval notation. And I need you to write it in set builder notation. I don't know if you remember, but when we first started doing the worksheet last Thursday, I said there's going to be 3 ways that you got to be able to write domain and range. We're only going to deal with 2, inequality and interval, and I'll teach you the 3rd one later. Well, today is later, okay? But it's nothing to stress out about, and you'll see why in just a second, I believe. I believe you'll see why in just a second, okay? You ready? What's my domain on this line? Everything greater than or equal to 2. So x is greater than or equal to 2. What does it look like in interval notation? Where does it start? At 2 and goes to how far? So infinity. Well, it goes around the infinity. Always. A parenthesis. Well, it goes around the 2 in this situation. Why is it a bracket? And it's colored in, right? Colored in, okay? So, you know these 2. Can I teach you real quick about the set builder? And then I think you'll understand why I didn't stress out about it. Okay? A set builder means we're writing in set notation. When we're writing in set notation, it's like these sets of numbers. See how I wrote these pretty braces? So we're going to have a pretty braces. We tell our reader what variable we're talking about. What variable are we talking about? Variable. X, and then we say such that, and we draw a vertical line. X is greater than or equal to 2. Done. That's set builder. It's not the same. It's set builder because we have to write the set builder notation thing here. We're telling our reader we're dealing with an X, but this is the same, isn't it? That's the same as inequality notation. Do you see why I didn't stress about it? Okay, so let's go. Are we ready to go on the next one?
Yes.
All right. This is totally one of those times that if you're more comfortable with using some colors to help you differentiate what we're talking about, this would be a great time to use it. Okay? And I see several of you doing so. I just wanted to validate that for you, okay? So, what is this in inequality notation?
X is less than 4. Because it's not colored in.
Correct. That's exactly right. Okay, it's not colored in, so it's just less than. And it's going to the left of our number, so that's less than. Okay? What about interval notation? Remembering that we always do at least to greatest.
Bracket.
Parentheses, why, Jennifer? It keeps going, so we put negative infinity. And where does it stop at? 4. but 4 is not included. So we put a parenthesis. The 2 is included and it's colored in, so we have a bracket. We also have a greater than or equal to symbol.
The only times you put a bracket is if it's colored in
Correct?
and it starts.
Correct. This one's not colored in, so we have a only less than, or, this case it's less than. It could be just a greater than if it was pointing to the right, and a parenthesis.
And we start with the negative infinity because
We start with negative infinity because we always go least to greatest, always left to right. Okay? What about set builder? X, good. X such that X is less than 4. Can I try to trick you? Okay. Yes, you definitely write this one. It's definitely part of your notes. So for most people, interval notation is easiest to start with on this. Why? Because it goes from -1 to 5. What goes around the -1? A parenthesis because it's not colored in. It's an open circle, so it's not included in our domain. So we have a parenthesis when it's not included in our domain. What goes around the 5? A bracket because it is included in our domain. It's colored in. Okay? So what about inequality? So while that is correct, it's not the best way to write it. Do you mind if I show you the best way to write it? Okay? Because would it be appropriate to say that X is between -1 and 5? Okay, that's not exactly right, just for the record. It's really between -1 and 5, including 5. Okay? But could I write this? Isn't that saying that X is between -1 and 5? So I just have to figure out the symbols that go here, right? How is X related to 5? It's less than or equal to 5, right? How is X related to -1? It's greater than -1. So watch this. Everybody watch and then write. Watch first. I heard you very clearly say it's greater than -1. And then some people looked at this and said, except you drew a less than sign. Guys, I need you to understand. I drew the sign in relation to the X. And if I'm reading this in the relation to the X, I'm saying X is greater than -1. See how I'm reading it backwards? So if I'm reading it backwards, I have X is greater than -1. I know that you've always been taught that that's a less than symbol. And that's true if the X is on the left-hand side. But right now it's on the right-hand side and we have to read it in the direction from the X. Do you understand why this is correct? Good. What's set builder? No, less than. You say less than because now we're reading it from left to right. So we say -1 is less than X. Because isn't that true? Isn't -1 less than X? For sure, right? Is less than or equal to 5. So in your homework, you're going to asked to do several things. Up here at the top, it's going to give you some words and ask for the set of numbers in a list. Can you do that? In your homework also, you're going to be asked to, I give you the graph, you give me an equality. Can you do that? What if I give you interval? Can you give me an equality? What if I give you set builder? Can you give me the graph? It's a different combination of all of these. I started with the graph every time when we wrote the rest, but could you go backwards the other way? Okay, or just go in between two of them? Good, because that's what you're going to need to be able to do. Okay? Now, in a perfect world, everyone already has their Chromebooks. and I assign you your homework on your Chromebook with your online book. However, not only does everyone not have their Chromebook yet, but the online book publisher is struggling setting up my classes. Isn't that so great? So I copied the book for you today. I have a page for each of you. Okay? You see what problems to do on the sideboard, yes? Okay, do the problems that I ask you to do, please. You can do it on this paper or you can do it on a separate paper. It's totally up to you. But there's definitely more than enough room out here in the margins to do the problems that you need to do. But to be fair, if you feel more comfortable doing it on notebook paper, that's fine as well. Okay, do you have any questions about this? Peace.